Hi students of grade 11. I have compiled practice questions that will challenge your understanding. I encourage you to watch the video, try out the questions presented in the video, and then showcase your brilliance by sharing your answers in the comment section below. Don't forget to include your name and your father's name initial to personalize your responses. Or for that extra touch of personalization, just include your name as well as your father's name initial. Without any further ado, let's dive in and conquer those challenges one question at a time. Suppose reactions A to B and B to B are both elementary processes with rate constants 8 times 10 to the power of 2 for the first one and 4 times 10 to the power of 4 for the second one, respectively. What is the value of the equilibrium constant for the equilibrium? Which of the following statements correctly describes a chemical reaction at equilibrium? Is it concentrations of the products and reactants are equal? So remember the characteristics of a reaction at equilibrium. B, the change in the concentration of products and reactants is constant. C, the rate of forward reaction is less than the rate of reverse reaction. And D, the rate of forward reaction is greater than the rate of reverse reaction. Which of the following statements is true about equilibrium reaction? It's almost similar question. No more reactants are transformed into products. There are equal amounts of reactants and products. The rate of constant for the forward reactions equals that of the reverse reaction, and the rate of forward reactions equals to that of the reverse reactions. Question number 4. Which statement is true about chemical reactions at equilibrium? They are very similar concepts. But remember the characteristics of chemical reactions at equilibrium. It's very important that you remember this concept. The forward and backward reactions proceed at equal rates. B, the forward and backward reactions have stopped. C, the concentrations of the reactants and products are equal. And D, the forward reaction, I have to say, is exothermic reaction. Now, in this question, you are asked to write the equilibrium constant expression for the reaction that is given here. Question number 6. This is a very interesting question. A 0.1 molar solution of hydrochloric acid is dissolved in water. What species of ions are present at equilibrium? Second, what will be their concentration? Their equilibrium concentration, rather, of the species that are present at equilibrium. In which direction will the following equilibrium shift if a solution of sodium ethanoate is added to this chemical reaction? Will the equilibrium shift to the right and produce more products, or will it shift to the left and you'll have more reactants, or no change, or that the reaction cannot be predicted with the given information? The hydrogen used in the Haber process is made by the following reaction. So you have to remember the Chattelier's principle. So the reaction which is given here is an endothermic reaction, right? Because the change in enthalpy is positive. Which of the following sets of conditions will favor the formation of hydrogen? Is it low pressure and high temperature, high pressure and low temperature, low pressure and low temperature, high pressure and high pressure. In which of the following systems will the position of the equilibrium shift to the left, meaning you will have more of what? Reactants. Upon an increase in pressure, but to the right upon an increase in temperature. So let me explain this. When you increase the pressure, the equilibrium would shift to the left and produce more reactants, whereas if you increase the temperature, the equilibrium would shift to the right and produce more products. So you have 4 choices, and 2 of them, choice A and C, are endothermic reactions, but with different number of moles, whereas B and C are exothermic reactions, and similarly the number of moles are different. By applying Le Chatelier's principle, you should be able to decide which system fulfills both these 2 conditions. Alright, question number 10. So the following equilibrium constants were determined at 300 degrees Celsius. Remember, the K value is constant for a specific temperature. For the first equation, we have Kc value of this 4 times 10 to the power of 18, and for the next equation we have for another the specific Kc value, which is 4 times 10 to the power of minus 31. So the question is, what will be the equilibrium constant of the overall reaction, which is given here? Well, the value of K equilibrium for the following equation is 0.25, and the equation is right here. What is the value of the K equilibrium at the same temperature for the reaction below? Similar question, at 298 Kelvin, the following 2 gaseous equilibrium involving SO2, SO3 and oxygen are established. So for the first reaction we have K1, and for the second reaction we have K2. Which of the following equilibrium expressions is correct? So you are asked to relate K1 and K2. Question number 13. At 445 degrees Celsius, Kc for the following reaction is 0.02, and the reaction is here, given here. A mixture of hydrogen iodine and hydrogen iodide in a vessel at 445 degrees Celsius had the following concentrations. So these are initial concentrations. Concentration of hydrogen iodide is 2 molar, and that of hydrogen is 0.5, and that of iodine is 0.1 molar. Which of the following statements concerning the reaction quotient, which is QC, is true for the above system? So Kc and QC have the same form, except that in QC the concentrations are not necessarily equilibrium concentrations. So by calculating the value of QC and comparing it to Kc, you can predict which way the reaction proceeds to establish equilibrium. Considering the reaction below, which is written here, in which of the following will the effect of concentration and temperature simultaneously cause an increase in the rate at which products are formed? So as you can see, the reaction is an exothermic reaction because heat is produced or released into the surrounding. All these species are in gas phase, and given the enthalpy change, which is plus 180 kilojoule per mole, which indicates that the reaction is an endothermic reaction. The value of Kc changes with, is it A, change in pressure? Is it B, introduction of nitrogen monoxide? Is it C, change in concentration of hydrogen? Or is it D, which is change in temperature? The reaction below, K equilibrium is 100, is equal to 100. What will be the concentration of oxygen if the concentration of sulfur dioxide is the same as that of sulfur trioxide? Which of the following mathematical relationships between K, K1 and K2 is correct? And for the first reaction, the equilibrium is K1, and for the second reaction it's K1, and for the third it's K2. Just try to come up with a relationship between these three K values. Question number 18. The value of Kc for the following equilibrium reaction is 4 at a temperature of 373 Kelvin. And the reaction is given here. What mass of ethyl methanoate will be present in the equilibrium mixture if 15 grams of acetic acid and 11.5 grams of ethanol were mixed and equilibrium was established at this temperature? Okay, so you are asked to calculate the mass of ethyl methanoate that would be present in the equilibrium mixture if 15 grams of acetic acid and 11.5 grams of ethanol were mixed and equilibrium was established at this temperature. Number 19. Which changes will increase the amount of sulfur trioxide at equilibrium? And this reaction is exothermic reaction. Is it increase in temperature? Is it decreasing the volume? Or is it adding a catalyst? So three gases are in equilibrium in a closed chamber sealed with a piston. The following equilibrium is established. So the species are ammonia, nitrogen and hydrogen. What will happen if the piston is pushed into the chamber? A, the molar fraction of nitrogen increases, the mole of nitrogen decreases, the mole fraction of nitrogen remains the same, the mole fraction of nitrogen increases and then decreases. The reaction for nitrosyl chloride is given here, and the value of Kp for this reaction at 25 degrees Celsius is 1.9 times 10 to the power of 3. What is the value of Kc at this temperature? Question number 22. If the following reaction is at equilibrium, which one of the following changes will shift the equilibrium to the left? Provided this reaction is an exothermic reaction. Is it increasing pressure, adding more nitrogen and hydrogen, decreasing temperature, or increasing the volume of the reaction container? Which of these changes will shift the equilibrium to the left, meaning to produce more of reactants? Consider the following equilibrium reaction. Which of the following mixture, each placed in a closed container and allowed to stand, is not capable of reaching the equilibrium given above? Is it pure calcium chloride, B, calcium chloride and calcium oxide, C, some calcium oxide and a pressure of carbon dioxide greater than the value of Kp, and D, some calcium carbonate and pressure of carbon dioxide greater than the value of Kp. Question number 24. Consider the following reaction. What will happen if sodium hypochlorite is added to the above reaction at equilibrium? Would the concentration of both hypochlorous and hydronium ion increase? Would the concentration of both hypochlorous A. Would the concentration of both hypochlorous acid and hydronium ion increase? B. Would the concentration of hypochlorous acid and hydronium ion decrease? Okay, C. The concentration of hypochlorous acid would increase and concentration of hydronium ion would decrease. And D. Concentration of hypochlorous acid would decrease and the concentration of hydronium ion would increase. Question number 25. Hydrogen sulfide dissociates on heating to produce hydrogen and sulfur. 0.1 mole of hydrogen sulfide was put into a 10-liter vessel and heated to 1132 degrees Celsius. It gave an equilibrium mixture containing 0.0285 molar hydrogen. What is the value of Kc at this temperature? Question number 26. What is the equilibrium constant expression for the following reaction? That's all I have. Thank you for watching.